I am, if you, yep.
There we go.
Yep, I'm from
This is
Houston,
us.
Texas, and this is us.
So I'm Fletcher Nichol. I'm the one on the right here. I'm from the northernmost country in North America, so I'm from Canada.
The better one.
These are our Twitter handles. I've been working on this project Habitat for I think almost 3 years, so I'm pretty set in my ways maybe at this point, or pretty into it. With that, so our talk today is to talk a little bit about Habitat, a bit more specifically about a particular aspect of it, and then how the work that we're doing to kind of help make the experiences in Kubernetes specifically more compelling and interesting, to see kind of like what does Habitat sort of bring to the table to help out in the Kubernetes space. So Habitat itself encompasses a lot, but we'll just sort of boil it down to a reasonably small statement that's kind of compact. So you can think of Habitat as what we call application automation. And this is basically a way to let application teams and operators and release engineers kind of work together collaboratively to package any kind of application, so any runtime or native code that ultimately could be deployed in any environment. So this is bare metal and servers. And in this case, though, we're talking at a Kubernetes conference, so it works really well in Kubernetes and in containers as well. It just so happens it works in others. The way that we're doing that is by embedding some kind of smarts and automation into an artifact that ships with your application. So this we call like it's automation that travels with your application. How we're doing this is by having an application package definition. So it's basically a bit of a packaging story that sort of feeds this whole system. And when you're looking to package your application or service up in Habitat, this is the place where you're informing Habitat about the needs of what your application or service needs to be built with. So that might be compilers or tools or libraries, what it needs at runtime, like separate from build time. So I might need this linked library. I might need the specific version of the Erlang VM or Ruby. Additionally, other things that it might need at runtime, like collaborating services. So in Habitat, we're very kind of microservice first sort of oriented. And you typically can't get very far with a sort of a distributed system with a service that really talks to nobody or has nobody that talks to it. So largely, when you're working in these environments, it's sometimes hard to trace who depends on me or who do I depend on. So that's kind of another activity or thing that you're putting into this application definition, so that when we're producing sort of an artifact afterwards, all of that intent, information, needs, wants, desires, whatever, is in that artifact that the other software components in Habitat can then use to know how the thing wants to behave sort of at runtime, how it would expose its notion of health, how it would react to like a configuration change, how it wants to be updated, and that kind of thing.
And Habitat's also completely open source, right?
So yeah, so Habitat as a project is entirely open source. It's on GitHub like many other projects are. It's licensed under the Apache v2 license. I would normally have said before, it's all also in one repo. It's kind of a lot of code. We have this year done a little bit of a step into having a couple different repos. I think we're up to three?
Yeah,
maybe four at the most, which has been interesting. But it's all under the Habitat organization. So kind of drilling into one of these software components, one of the parts of Habitat is what we call Habitat Builder. And at its core, it's both a distributed build system, but also sort of a package repository, and the two sort of are integrated in together. In terms of the package repository, our Habitat packages are somewhat unique given like what we wanted to get out of the packages, mainly like the smarts about application lifecycle. When the packages are hosted in Builder, they can be promoted into what we call release channels. So if if anyone's used any software before that has sort of like a channel release model, or if you've tried the like Chromium like dev builds of your web browser as opposed to the stable branch, it's kind of the same thing. It's sort of you choose what you want to consume based on stability or needs or environment and that kind of thing. So we're able to sort of release or promote these specific artifacts into a channel that other parts of the system might be consuming and looking for. That's how they would get their updates and know this is when I update and it's this version and that kind of thing. And sort of feeding into this, Builder's also integrated with like source code if you want to. So like to be able to attach a GitHub repo that has your source code, and the software definition ideally is sitting with your code. So Builder knows basically how to check that out like on a master merge or some change to rebuild your application, and then to store it so that you can choose to have that go off to a test environment or UAT, kind of whatever you want. Right now, we, again, Builder itself is also open source. We run one for kind of the benefit of the community. So it's hosted, and you can upload your own packages. You can host your own packages and connect plans to GitHub. We've got builds. If your packages need to be private, they can be private. If you want to run parts of that yourself, we're kind of getting into that territory of also being able to better support people wanting to run parts of Builder on their own. It's not to say that you can't. It's just that we are, on the engineering team, we're also the operators of Habitat and the SaaS. So we run Builder using Habitat, consuming and building its own packages. So we try to keep it really honest. And in that spirit, hopefully we're the trailblazers and we find the rough edges first and figure out what is the best operable model before we give that off to other people. So I think it's something I wouldn't want to give up as an engineer, is operating my own product in this way. The learning is just too good.
Yeah.
So we've kind of got a lot of primary users that we've got in mind. Largely, it's application teams and people closer to the applications and services. Also platform services teams, because Habitat can also deal with packages you don't write yourself, like Postgres or MySQL or like third-party software. And basically anybody that is going to touch software or an application in its life cycle.
Yeah, so sort of why we built Habitat is because we recognized that there were some underlying like issues or problems with the way that like people package and manage the packaging of containers and the runtime there. And so one of the areas that we primarily focus in is that, or one of the problems that we identified was that your application was coupled to your operating system or your distro or your platform or whatever. So one of the aims of Habitat is to decouple your application from the OS so that you don't have to do something like from Ubuntu or from CentOS in the top of your Docker file. Habitat actually, when you build a container in Habitat, it's actually from scratch. So it's just your application in the container. One of the other issues that we see in the Kubernetes space is like managing configuration. So when you need to make a configuration change, sometimes you might have a hybrid workload where your application's running in AWS or on a VM and also in Kubernetes. How do you manage the configuration disparity between those two things? So Habitat manages all that for you because all the logic for that is encoded in your application. And then the final problem that Habitat aims to sort of target is that nobody wants to really rewrite their application to be cloud native, right? That's expensive for the business. And so our aim is to enable your application to be cloud native without having to use something like etcd or console to get your application's configuration to you, and your app having to be aware of how to do that.
Unless that's like necessary.
Unless it's necessary for your thing.
If you need the value of a key value store, that's perfect. If you just need some service discovery, that's something that kind of like Habitat can give to you, sort of by nature of how it works.
Exactly. And so some of the current tools in the space that are tackling this problem, right? The same sort of things that Builder aims to tackle are Jenkins and GitLab, right? They have build pipelines, they manage your source control, and they prove out that that integrated workflow from code to production is valuable, and they provide an easy on-ramp from code to that Kubernetes deployment, but they still require you to like shape your application in a way that is container, like it needs to know about it, what the runtime that it's going to eventually execute in. One of the other tools that we looked at was App2Me, and so they show that the packaging format is super important, and that if you can get the packaging format right, it's easy to distribute your application. And I don't know, if you haven't seen them, they've got a really interesting approach to deployment also. The trouble is, App2Me is Kubernetes specific. So if you have applications that need to run still in VMs or still on bare metal, you're still left with some last mile work to do.
So we have a lot of customers we've seen are kind of, they're sort of like straddling that sort of two generations of sort of the infrastructure they have today, the runtimes they might want to go to tomorrow, potentially with the same code base, and it's hard to know, like, do you start writing forks of two apps or have two different deployment models? So this is something we're trying to help with in Habitat, is have a way to still go back to the roots of how does this thing work, what does it need, and then try to help make sure those kind of needs are realized. So it's more of a package kind of concern up front that you get, which this is what allows us to run sort of the same Habitat package on a bare metal host, but also in a container, and it kind of works the same.
That's a great segue for the next slide.
Look at that. All right. So this is kind of a way that some of us have sort of thought about, at least the approach to sort of building, or where you, I think of it more as like where I want to be spending my time as an engineer working on an application or service, is I want to be thinking about my application or my service, not necessarily what platforms I need to build it on, what what library, what version of whatever native library do I need to build it. And so traditionally, when you've been dealing with sort of normal like servers or virtualization, you're kind of thinking in the operating system space, or like what package repositories do I need to pull the thing in, or what region am I in to get like the right version of something. In the container space, I think that's been made a whole lot easier, because the concerns that you need to worry about are a lot less. It's still a little problematic, at least from my point of view, is about the best we can sort of do is draw a bigger circle around the application, sort of start from a common base of, like, maybe it's something that looks like a minimized Ubuntu installation or Alpine, or it's basically like some user land and some libraries. You don't know if that's actually in the runtime path of your application or not, but it tends to run with it. And that's all right. You can get into issues sometimes when you might have some software that's sitting with your application. You're not sure if that's actually a factor or not in how it runs. So this comes up sometimes when vulnerabilities come up. So you might know that, like, in this Docker image, I have a troublesome, like, I maybe have a version of OpenSSL that I might have a problem. But then there's also the question of, like, does my app even use it? So if it doesn't use it, do I still even care? So with Habitat, because we're sort of, we just want to think application first, and then everything flows down. Everything else is in support of that. And so our packaging system, if you don't use OpenSSL, you don't get OpenSSL, and it's not installed alongside. If it is, we know the version, we know what it got linked to, and that's something that we can provide, like, statically, just statically analyzing a package, or also sort of at runtime with the ability to sort of like query that service to ask, like, what is the software you have running? So if you need to do sort of like fleet-wide, you know, like survey to see, like, right, do I have a problem or not?
Right. And, you know, another great example of this, we were at a co-working space on Monday or Tuesday, and we were talking to some developers there, and they were saying, man, you know, the other day we shipped out a production deployment of our Python app, and one of the developers added a dependency that we didn't know about, and we pushed the app out, and the dependency wasn't on the OS that we pushed it to, so production got broken. And that's a huge problem that the Habitat build system solves, because you would have caught that up front at build time before you ever shipped it to production, because all those dependencies are going to be shipped with your app.
So I only laugh because I know I got hit with this even last week. So it's not a production problem, like we didn't have a problem, but it's sort of like, why is this Habitat package breaking? Oh, somebody introduced a new native library, and they forgot to update our like definition of it. So at the end of the day, like if I can catch more of this at build time, it makes me happy.
Exactly.
Less runtime surprises.
So cool. So once you have all that Habitat stuff, once you have Habitat wrapping your application, how does it get you to Kubernetes? So what we have is we have exporters for Habitat. So we support, right now we have exporters for Docker, Kubernetes, which is basically a Docker export with a YAML file, a Helm chart exporter. We can also export to the Amazon Container Service. And so what we do is we just leverage the best parts of Kubernetes, and we leverage the best parts of Habitat that wraps your application, and we can make those things work together in such a way that it's easy to get your legacy apps, your new apps from code to production super, super easily. One of the other tools that we leverage I feel like maybe it's not so new, but it's sort of new, is the Habitat
basically
operator.
The last year we've been working on it,
Yeah.
So it depends. In Kubernetes time, that might be a long time. I don't know. Things move really fast, so.
So one of the other tools that we've recently written is an operator for Habitat. So that allows you to manage your application deployment sets, stateful sets, and manage all the configuration changes that need to happen for your application. And I'll get into more detail about that in a minute. I've got a whole slide towards the end on it. And then the last tool that we provide for the Kubernetes Habitat integration is an open service broker API implementation. So basically that's going to enable you to deploy your app in Kubernetes, to deploy it on Amazon or Azure, wherever you've got an open service broker API implementation, and connect those two things easily.
So it's like a way to kind of bridge services you might still need, but either can't or aren't currently on the same like runtime. So a way of basically kind of bridging worlds together, and we're never really sure how to present this because it seems like it's still sort of a new thing, but I think it's gaining some traction in the community. It kind of came out of Cloud Foundry. You can see a lot of the big cloud providers are starting to have like a broker API endpoint with a service catalog for some of their offerings. Yeah. So this is also a place that we knew that we wanted to be doing some work.
Definitely a goal that we're driving towards.
Yeah. So this is kind of a bit of a shortened image about sort of how we think about an application through its life cycle. And by life cycle, that's not necessarily like from boot time through that stage. It's kind of like from code to running in production to upgrading to health status and all that. At build time, there's, I guess, a couple things going on. We have, again, this notion of a package definition. In Habitat, it's effectively, we call this a plan, which is not too complicated thing. I think we'll see an example. You can check out our website if you want to see kind of more concretely what that looks like. And that gets fed into a build system that understands these plans and produces an artifact. So kind of like code plus plan equals artifact. And if the artifact happens to have a runnable service, you can start that and it becomes a service. Builder is both kind of the mechanism, like the resting place for where those artifacts can go, but also a place where you can have those packages be sort of automatically rebuilt and have just sort of the pool of compute to sort of do that work without worrying about, it's still possible that you can still make your own pipelines and have Habitat builds discretely, but if you don't care about that so much, or if you want to take advantage of some of what Builder does, sort of some dependency rebuilding, that's kind of what's going on in Builder. So the next kind of step on this is deploy. I think for the purposes of this talk, I kind of think about it more of like cross-publishing or exporting. So again, I think Elliott mentioned our package exporter. So it's a way to take sort of a Habitat package and then say, I could probably just, make a Docker image from this, or like a tarball that contains all the packages, relative to this, that you could just untar on a server and then it works. So we've got, I'm not even sure, fewer than 10, north of 6, I can't remember.
Yeah, 5 exporters currently.
So I guess for the benefit of this audience, we have like an exporter for Docker to sort of make a Docker image, one for Kubernetes, which is like the Docker image plus a deployment YAML, a Helm exporter, which gets you sort of like the chart. I think I got the right term for that. Builder itself also, for a few of these exporters, we have a bit more of like a sort of long-lived integration that you can take, that you can basically trigger an exporter when a package gets rebuilt. So right now, we have an integration that you can publish out to Docker Hub, and I believe Amazon's ECS. I'm looking at you because you wrote that one.
It's been a while,
okay.
yeah. The acronyms, or the letters, they always confuse it. It's the container registry for Amazon.
So it's a way to kind of get your application marching closer to production in a place where now it's closer to being consumable. And we'll use one of these, I think, in the demo here.
Yeah. And then once you get an export, you want to probably run the thing. And so what we allow you to do is you can run it on Kubernetes, you can run it on a VM if you want, you can deploy it out to Amazon and run it on a VM. And for the benefit of this crowd, what we do when we do the export for Kubernetes, I believe the Helm chart, is we actually embed that with the Habitat operator syntax. So that allows the Habitat operator to manage your application inside of the Kubernetes cluster, so that we can do things like manage the configuration, manage the service bindings and things like that. Which leads me to the Habitat operator slide, the one that I promised earlier. So the Habitat operator is just it's a Kubernetes controller. It's just like any other operator, like the etcd operator. I think Rook has one also. And it's designed to basically manage your application inside of Kubernetes. So it allows you to interact with Kubernetes in the way that you're comfortable with today, because it's just a service definition in your YAML file, and then the Habitat operator will take care of the rest of managing that Habitat application for you. What's great about that is you can front load all of the automation that your application needs to know about, and then you don't have to worry about orchestrating any of that automation on the back end once you deploy it. And the other really cool thing about the Habitat operator is that it can manage multiple services. So since the Habitat artifact is generic and it provides a consistent API, you can have one operator per namespace to any number of running Habitat services, any number of language. I mean, you can have services in Go and Ruby and whatever, and the operator knows how to manage all of those for you. So it's one operator to one service, which is pretty cool. And so I think next is the demo.
Yeah, all right.
So what we're going to show first probably looks pretty familiar to everybody. We're going to show off the Kubernetes operator deployment, or how you would deploy the Habitat operator, and then how you would deploy, you can go ahead.
All right.
How you would deploy the Habitat updater service. Traditionally, a Habitat artifact will update itself if it's running on VM infrastructure, but that doesn't really fly in Kubernetes, right? You don't want your underlying container definition changing out from under you. So the Habitat update service will watch for changes for Habitat services that are deployed in Builder, and once it detects that a change has been promoted, then it will orchestrate an update with Kubernetes. So so right now we've deployed the Habitat operator, and then we're getting the updater deployed. This is really just an example to show you like how easy it is to get all of these sidecars running. Cool. So now they are all up and going.
That's probably the end, right? No.
Oh wait, what am I doing? Oh yeah. So this is the log output from the updater service. So basically, it's just going to say that it's running and it's watching for service updates. And there's one service loaded. That's the other cool thing to note about the Habitat updater. It is a Habitat package deployed with the operator, so it will watch for updates on itself and automatically upgrade itself when there's new versions published. Cool. And then we have one more thing to sort of show off, and that is how does this work end to end, right? Like, so you make a change to your code. You can go ahead and start it. Yeah. So you've made a change to your code base here. I'm going to do a change to change a config file in one of our Habitat plans. This is Redis, and so I just turned protected mode on because, you know, security. And and so I'm just going to commit this change to the master branch of my personal repo.
I hope it's your personal repo, because
yep.
normally we
I
pull
almost messed that up.
That
was a late night demo recording. So I'm going to push that to master.
Oh, personal master. Okay, you're fine.
Yeah.
You're good.
Yeah. And so once I push that to master, you can see the builder automatically kicked it off. I didn't have to do anything.
So this is basically the builder like web interface. What you're kind of seeing here is the build system inside it that's just streaming back.
And I sort of did this cooking show style. I cut out the Redis build because it, you know, takes a minute. And so I'm just going to click a button to promote it to stable, and that's all I had to do. Like, now this is going to get automatically deployed out to my production environment because my production infrastructure is tracking the stable channel from builder.
I just paused it there because that promote button
like,
to me is kind of the payoff. So it's a way of saying we made an artifact. You could think of it as a release candidate in this like CD sense. We've basically promoted that, so we want that to be like pulled into the system. That's the thing that the updater is basically keying on, looking for, and that's going to trigger ultimately a Kubernetes deployment in the normal way that like Kubernetes would do its rolling deploy. So there's no real extra magic, but that's sort of how like a package promotion Habitat yields like the Kubernetes deployment, and that's how you get the update. So I hope that's like okay to reason through, but
yeah.
So to me, I was really excited the day that we added just a little web UI thing. We do have a CLI as well, and I live in my terminal all the time. So I don't know why the day this button showed up, I was like so excited.
I was too, because then I was pinging
people. I was pinging people late on a Friday night to be like, "When did you add this? This is amazing." Anyways,
thank you for being awesome. Cool. So now, in just a minute, I think I forgot to clip this one. But so what you're going to see is the Habitat updater is going to detect a change in Builder, that there was a new package promoted to stable. And it's going to orchestrate that update, a rolling update within the Kubernetes cluster, the default, or it'll orchestrate whatever the default is defined in your.
So this is basically the updater that sees by way of the operator that, oh, I got a Redis service going on. I should check for updates so that when that happens, I can basically coordinate a deployment.
Exactly.
So it's the one that's basically sitting off to the side looking at that. You didn't need to tell the updater that there's Redis going on because that was the operator that helped make that happen.
Exactly. Yeah, we automatically watch for Habitat packages running inside the cluster. Yep, and so you can see that the container that was there is now terminated and a new one has been created. And so for the very, very last part of this demo, what we're going to do is show a configuration update. So normally what this means in a Kubernetes context is that if you want to deploy a configuration change, you're probably going to have to kill your container and start a new one. But what Habitat allows you to do, and what the operator allows you to do, is it's going to manage that config change for you, and it's going to not roll an upgrade out, but it's just going to make that config change inside the Habitat package, and it's going to restart it and update it on the fly. So what this is useful for is, I think I might have missed the change, but basically I just turned on debugging for Redis. And the way that you apply this change is you base 64 encode a TOML string because that's the config format that we use. And once you apply that to your Kubernetes YAML, then the operator will orchestrate that change for you. And you can see here that it restarted Redis, and now you can see that debugging is enabled.
So yeah, so for Redis, I don't think it can cope with like an on-the-fly config change. So the behavior for Redis is to like restart. Your app, you might be able to send it a SIG-HUP, and then maybe it can cope with that change. All the smarts, though, and that knowledge that was in the Habitat package, which is how we can get away with knowing how to cope with a configuration change, while also not bringing that container down like unnecessarily, because maybe that's not a full deployment activity you necessarily need to do.
Cool.
And okay.
Yeah, that's it. What questions can we answer for you?
Sure.
Yeah. Oh.
Should we try this?
Yeah.
Or can you? Yeah. Ian's also on the team, so he can help with this part, I bet.
Okay. Can the builder be self-hosted?
Can the build? So,
Can the builder, the UI that you were just showing, can that be self-hosted?
Yeah.
so it is self-hosted. Pardon me?
Yeah, it's on-prem. So we do allow you to, so you can currently, in its current form, we'll allow you to host artifacts, but we don't provide the actual building and reverse dependency building of services in our on-prem service.
So yeah, we're working towards that.
Yeah, we're working towards it. It's just not currently available.
Yeah.
What's up? I can't really see, so.
These lights are awesome.
All right.
All right,
Cool.
thank you very much.
Thank you very much.